Hi everyone, this is your Aparna ma'am. Today we are going to discuss about one more important concept, that is stoichiometric and stoichiometric calculations. First question arises in our mind is that what is stoichiometry? It is a branch of chemistry that deals with the relative quantities of reactants and products in the chemical reaction. So take an example here. Nitrogen reacted with hydrogen, it gives rise to ammonia molecule. Okay, here what is the relation? One molecule of nitrogen react with three molecules of hydrogen, and it gives rise to water, two molecules of NH3 in terms of molecules. Or 1 mole of nitrogen reacted with 3 moles of hydrogen gives rise to 2 moles of ammonia in terms of moles. Okay, in this concept we are going to discuss about calculation of relation between reactants and products. Means here the amount of reactant is given, they may ask the product, or amount of product is given, they may ask the reactant. Those are called as stoichiometric calculations. Okay, here in stoichiometry can be used to find quantities of such amount of products in terms of masses, moles or volumes. Means here we are going to calculate amount of products in terms of mass, moles or volumes. In sometimes they may ask the quantities or amount of reactant also. Okay, yes, next we have to move towards calculation. Very important concept, how we can calculate. In calculation there are some steps. First one is write down the balanced chemical equation. First step is that write down the balanced chemical equation. Second point, write the relative moles or masses of the reactants and products below their formula. So by seeing the formula, we write the moles or masses of the reactant below their formula. In case of gaseous substance, we write down 22.4 liter at STP below the formula. We already know that this is a standard value. If the reactant or products are gases, we use 22.4 liter. And finally, by applying unitary method, we get the answers. Means we can calculate easily by applying unitary method. Okay, so what relations are given? They may given mass relationship, or mass volume relationship, or volume relationship. So in numericals these types of relations are given. By knowing one, we may calculate another one. Okay, so directly now we move towards numericals. Okay, as first numerical, very important part of the video, that is numerical part. Okay, first numerical, find the mass of CO2 produced when 8 gram of CH4 is combusted in presence of excess of air. Okay, here combustion reaction is given, means combustion of methane is given. We already know that any combustion reaction of hydrocarbon, any hydrocarbon, when it is heated with oxygen, heated in presence of oxygen, it always gives CO2 and H2O. Okay, yes, here combustion of methane is given. Therefore first we have to write on the balanced chemical reaction. This is the first step of the calculation. So first CH4 plus O2 gives rise to what? CO2 plus H2O. On balancing we get 2O2 and 2H2O. Okay, below that we can write the mole ratio. Okay, 1 mole, here 1 mole of CH4, 1 mole of CH4, 2 moles of O2, both are reacted to form 1 mole of CO2 and 2 moles of H2O. Is this clear to everyone? So how we can write here? By taking stoichiometric coefficient. Here stoichiometric coefficient is 1, therefore this is 1 mole. Here 2, therefore this is 2 mole. Here stoichiometric coefficient is 1, therefore this is 1 mole. Here stoichiometric coefficient is 2, therefore this is 2 mole. Is this clear to everyone? Understood? Okay. Next step, what they given? They given the mass of CH4. Mass of CH4 as 8 gram. 8 gram of CH4 is reacted with oxygen, gives rise to carbon dioxide. They ask the mass of the CO2. Now we calculate mass of CO2. What is mass of CO2? Okay. For that, we take a relation between methane and CO2 only. We don't bother about other reactants or products because here the relation between methane and CO2 is there. Therefore, you write methane and CO2 ratio. 1 mole of methane gives rise to 1 mole of CO2. Very, very important point. Here 1 mole of methane gives 1 mole of CO2. Okay. Yes, and 16 gram of CH4 gives 44 gram of CO2. What is 16? How we can write it? This is a molecular mass of CH4. For carbon 12, hydrogen 1, hydrogen mass is 1, 4 hydrogens are there, 1 into 4 equal to 4, therefore totally 16. Like that, 44 is what? This is a molecular mass of CO2. Again CO2 for C 12, for oxygen mass 16, 4 here 2 oxygens are there, 2 into 16 means 32, 32 plus 12, this is equal to 44. So 16 gram of methane gives 44 gram of CO2. Okay, 1 gram of methane gives how much? If 16 gram of methane gives 44, 1 gram of methane gives 44 divided by 16 gram of CO2. This is unitary method. Very, very simple calculation. Don't bother about this. So 1 gram of methane gives what? 44 divided by 16 gram of CO2. Okay. Now 8 gram of methane gives what? 44 divided by 60 into 8. So on calculating 16, okay, 8 ones are 8 twos are, finally 2 ones are 2 twos are, we get 22 gram of CO2. So here 22 gram of CO2 is produced. They given what? 8 gram of CH4 and how much gram of CO2 is produced. This is okay. This is what we can calculate. Okay. So means we calculate mass of CO2 here. Okay. We already calculated, that is what? 22 gram of CO2. Is this clear to everyone? Any doubt? I will repeat it once again because this is very important concept. Here they given mass of CH4 and they ask mass of CO2. Therefore, we write the relation between CH4 and CO2 only. Don't bother about other reactants and products. Very important point. First, we write mole ratio by using stoichiometric coefficient. Here stoichiometric coefficient 1. Here also stoichiometric coefficient 1. Therefore, 1 mole, 1 mole. Is this clear? So, 1 mole of CH4 gives 1 mole of CO2. Like that, 16 gram of CH4 gives 44 gram. First, we have to convert it for 1 gram. Afterwards, given gram. Okay, is this clear? Yes sir. Next we move towards second numerical. Before going to that, so this is which type of relation? This is mass relationship. Mass is given and we calculate mass, therefore this is mass relationship. Okay, next we have to move towards second numerical. Okay, this is second numerical. Find the volume of CO2 and H2O vapors produced when 32 gram of CH4 is combusted in presence of excess of air at STP. Okay, now we calculate volume of CO2 and H2O at STP. Okay, again combustion reaction is given. Already I mentioned that in combustion what happens? CH4 reacted with oxygen, it gives rise to CO2 and H2O. Okay, again they ask what? Volume of CO2, volume of CO2 and volume of water vapors produced. Okay, first we calculate about CO2. Okay, for that we write the relation between CH4 and CO2, means we consider only CH4 and CO2 ratio. Okay, again 1 mole of CH4 gives 1 mole of CO2. Any doubt? No doubt, because here stoichiometric coefficient is 1, here also stoichiometric coefficient is 1. 1 mole of CH4 gives 1 mole of CO2. Is this clear? Okay, therefore 16 gram of CH4 gives 22.4 liter of CO2. Why? Because here volume is given 22.4 liter of CO2. This is standard volume. Volume is asked, not given. They ask the volume of CO2. Therefore, we write the volume, mass and volume ratio. Mass they given, they ask volume. Therefore, here we can write 22.4 liter of CO2. Is this clear to everyone? If they give mass, again we write mass ratio 16 gram and 44 gram as it is. But here they ask volume of CO2, therefore 22.4 liter. We already studied about this formula, mole and volume relations and their formula in our previous video. Please go through that video. That is also very, very important video. Okay, come to the point. Here 16 gram of CH4 gives what? 22.4 liter of CO2. Then 1 gram of CH4 gives what? Again unitary method, 22.4 divided by 16, this much of CO2. Therefore 13 gram of CO2 gives 22.4 divided by 16 into 32 gram of CH4 gives, here you can write it as 32 into 32, unitary method, simple mathematics. Okay, on simplifying we get what? 44.8 liter. So answer is what? 44.8 liter of CO2. Sometimes in MCQ they give an answer in the form of volumes, 1V, 2V, 2 volume, 3 volume, 4 volume, like this. We know that 1 volume equal to what? 22.4 liter. Therefore 44.8 liter equal to what? 2 volumes. Here answer is what? 2 volumes. Sometimes they given like this. Okay, is this clear? Understood? And they ask vapors, water vapors also. Again write the relationship between methane and water. 1 mole of methane gives 2 moles of water according to chemical equation. Yes or no? Here 1 mole is there. 1 mole of methane gives water, 2 moles of water. Okay, is this clear? Yes. Here again 1 mole of methane gives 2 moles of water. Any doubt? No doubt. Again 16 gram of methane gives what? 2 into 22.4. For 1 mole this is 22.4. Here 2 moles are there. Therefore 2 into 22.4 liter of water. Therefore 1 gram of methane gives 44.8 divided by 16. For 1 gram we convert like this. Simple mathematics. Therefore 32 gram of CH4 gives what? 44.8 divided by 16 into 32. Therefore on calculating, on simplifying this, we get 89.6 liter of water is produced. Any doubt? Any doubt? Okay, I think no doubt. Okay, yes. Next we move towards one more numerical. One more numerical here. If 10 volumes of dihydrogen gas react with 5 volumes of dioxygen gas, how many volumes of water vapor would be produced? Okay, what they given? If 10 volumes of dinitrogen gas react with that 5 volumes of dioxygen gas, how many volumes of water vapors are produced? Okay, again they first we have to write what? We have to write balanced chemical equation. Here reaction between dioxygen dihydrogen means what? H2 plus O2, both are reacted to form H2O. On balancing we get what? 2H2 plus 1 O2 gives rise to 2H2O. Is this clear? Again first we have to write down the moles. Okay, 2 mole of H2 and 1 mole of O2 gives 2 moles of water. 2 moles of H2, 1 mole of O2 gives 2 moles of water. What they given? 10 volume of H2 react with the 5 volume of O2. How many volumes of water is produced? Here in this numerical they gave 2 data, 10 2 reactant values, quantities, 10 volume and 5 volume. Okay, therefore what is the ratio? 2 mole reacted with the 1 mole, it gives rise to 2 mole of water. What is the relation between these two? 2 is to 1. Yeah, 2 is to 1. 10 volume and 5 volume. Again by unitary method, write down the relationship between hydrogen and water. 2 volume of hydrogen, 2 mole of hydrogen gives 2 mole of water. 2 mole of hydrogen gives 2 mole of water. Okay. Yes sir. 1 mole of water gives what? 1 mole of H2 gives 1 mole of water. Yes or no? 2 mole of H2 gives 2 mole of water, means 1 mole of H2 gives 1 mole of water. Therefore 1 volume of H2 gives 1 volume of water. Relation is same, 1 is to 1 actually. Okay. Therefore 10 volumes of H2 gives 10 volumes of H2O. 10 volumes of H2O. This is our answer. Is this clear? So by seeing all these numericals, we concentrate on mole ratio. Yes or no? We write first, we have to write the mole ratio. If once we write the mole ratio, then no problem. Okay. Is this clear to everyone? Understood? So this is what? Volume relation. In first numerical mass relation, in second numerical mass and volume relation, in third numerical volume and volume relation. Okay, next we have to move towards another numerical. Okay, very important numerical again. This is another method to calculate the stoichiometry. Okay, this is another method. From this numerical, I am going to tell you another method to calculate this problem. Okay, find the mass of CO2 produced when 5.8 gram of butane burnt in excess of air. This is a question. Find the mass of CO2 produced when 5.8 gram of butane burnt in excess of air. Okay, what is first point? First we have to write the balanced chemical equation. Again, this is combustion reaction. Products are CO2 and H2O. By balancing the equation, we get here 2, here 30, 8 and 10. This is another method. First we calculate the mole of the mole of CH4. Okay, and C4H10, sorry, not CH4, this is butane, mole of butane. Here first we can calculate mole of butane. Afterwards we start our calculation. What is the number of moles of butane? We already studied in our previous video. N equal to what? Mass divided by molecular mass. Here mass given is 5.8 and the molecular mass of butane, molecular mass of C4H10, okay, 4 into 12 plus 1 into 10. On calculating we get what? 58. 5.8 divided by 58 equal to what? 0.1 mole. 0.1 mole. The number of moles of butane, first we have to calculate the given data, means number of moles of butane. Butane they given a relation between butane and CO2 we calculate. Okay, mass of butane is given, therefore we calculate number of moles of butane first. Is this clear? Then write on the mole ratio. 2 moles of butane gives 8 moles of CO2. Again, only compare butane and CO2. Don't bother about any reactant, other reactants and products. Yes or no? Okay. Next, 2 moles of butane gives here butane. 2 mole of butane gives 8 mole of CO2 according to equation. Therefore, 1 mole gives what? 8 by 2. Again, unitary method. Therefore, 0.1, the number of mole of butane already we calculated as a 0.1 mole gives what? 0.4 mole. 8 by 2 into 0.1, we get what? 0.4 mole of CO2. What they ask? They ask mass. Therefore, mass equal to, we already know that number of moles equal to mass divided by molar mass. Therefore, mass equal to what? Number of moles into molar mass. Yes or no? Take it as a x. Therefore, number of moles equal to mass divided by molar mass. Here we can calculate mass. Take it as a x. Number of moles already calculated. This is 0.4. Okay, 0.4 equal to x divided by 44. We get 17.6 gram of CO2. Is this clear to everyone? First we have to calculate the mole of butane. After that, compare this and calculate the exact mole of the CO2. On calculating moles of CO2, we easily calculate mass of CO2. Number of moles of CO2 is what? 0.4. Therefore, mass of CO2 is 0.4 equal to x divided by 44. Therefore, x equal to 44 into 0.4. Why? Because we already know that number of moles equal to mass divided by molecular mass. Is this clear to everyone? Yes, sir. Next, we have to move towards next method. Find the mass of O2 required when 5.8 gram of butane is burnt. For same equation, here we can calculate mass of O2. Again, in equation what they given? Butane plus O2 gives rise to CO2 plus H2O. Now we can calculate relation between butane and O2. So according to equation, 2 moles of butane gives what? 13 moles of O2. 2 moles of butane gives 13 moles of O2 according to balanced equation. 2 moles of butane gives 13 moles of O2. Therefore, 1 mole gives what? 13 by 2 mole. Okay, ununitary method. 0.1 mole. 0.1 mole is what? This is mole of butane. We already calculated this one. 0.1 mole of CH4 gives 13 by 2 into 0.1. We get 0.65 mole of O2. Okay, on getting O2 mole, we may easily calculate mass. Okay, N equal to what? N equal to mass divided by molar mass. N equal to what? N equal to mass divided by molar mass. Okay, we get 0.65 equal to x divided by 32. On calculating, we get the exact mass of O2. Is this clear to everyone? Yes. Next we move towards one more numerical, very important numerical again. This is a PYQ. Okay, here CuCO3 gives rise to CuO plus CO2, copper oxide plus CO2. Okay, find the mass of CuCO3 required to produce 12.2 liter of CO2 at STP. Okay, they given CuCO3, find the mass of CuCO3, find the mass of CuCO3 required to produce 11.2 liter of CO2, means they given volume of CO2 11.2 liter and they ask mass of CaCO3, means this is volume and mass relation. So either you follow the first method or you follow the second method. What is the second method? First we have to calculate number of moles. After that we easily calculate volume, because we already know that number of moles equal to volume divided by 22.4 liter. By this formula we easily get volume of CO2. Or mass, what is mass formula? Mass divided by number of moles equal to mass divided by molar mass. This is a formula. Okay, once we calculate number of moles, we easily get mass or volume. Is this clear to everyone? Again, according to the equation, okay, 0.5 mole. How it is 0.5 mole? Already we know the calculation of the number of moles. Okay, 0.5 moles gives 0.5 mole of CO2. 0.5 mole of CO2. And therefore number of moles equal to what? Mass divided by molar mass. Therefore 0.5 mole divided by x divided by 124. On calculating we get what? 62 gram. 62 gram. How we get 0.5? 0.5 is the number of mole. 11.2 divided by 22.4 liter. On solving this we get 0.5. Take this 0.5 here. Is this clear to everyone? How this 0.5 we get? We get this 0.5 by the CuCO3 calculation. Is this clear to everyone? Understood? So 1 mole relation is there. If it is gives 0.5 mole, this is also gives 0.5 mole. Yes or no? Here the volume of CO2 is 0.5. How it is 0.5? Once again, 11.2 liter is given. We already know that calculation, N equal to V divided by 22.4. V is already given 11.2 divided by 22.4. On solving we get 0.5 mole. If 0.5 mole of CO2 is there is a 0.5 mole of CuCO3, because here also 1, here also 1. Mole ratio is 1:1. Therefore, if it is 0.5, this is also 0.5. Therefore, on getting mole, we easily calculate mass. Is this clear to everyone? N equal to what? Mass divided by molar mass. On solving, we get 62 gram. Is this clear to everyone? Okay. Next, we have to move towards next numerical. 2CaNO3 twice. Calcium nitrate gives calcium oxide, NO2, nitrogen, dioxide and water. Okay. Again, find the mass of CaO. They ask mass of CaO and 0.5 liter of NO2 is given. Means now we write the relation between NO2 and CaO. Here 4 NO2 gives 2 CaO. According to equation, we don't bother about other reactants or products. Is this clear? First we write the ratio between CaO and NO2. Okay. 4 NO2 gives 2 CaO. Means 4 mole of NO2 gives 2 mole of CaO. 1 mole gives what? 2 by 4 mole. Okay. By solving we get the mole 0.25. How it is 0.25? We already know that number of moles equal to volume divided by 22.4 liter. By using this formula, we get 0.25 moles. So 0.25 moles of NO2 gives what? 2 by 4 into 0.2 mole. On solving, we get it as a 0.12 mole, 125 mole of CaO. Therefore, mass of CaO equal to Mass equal to what? Number of moles equal to mass divided by molar mass. Therefore, mass equal to number of moles into molar mass. Okay. Molar mass on solving, CaO molar mass equal to 56. This is 40. Calcium is 40 plus 16. We get 56. This is a molar mass of CaO. On solving, we get the final answer. Is this clear to everyone? Understood? Yes, take down some homework question. This is very important concept, students. Please listen carefully, and you first make a notes, and after that you have to solve other numericals. Then we get the clarity in this concept. Okay. So these are some homework questions. Please do homework and comment your answer in comment box. Okay. Understood? Yes. Thank you.